Thank you for joining us. Quick introduction, Alec is the CEO of VGIS, a very innovative and frankly extremely cool virtual reality GIS platform. We've had the pleasure of working with Alec for quite some time now, and Alec, I'll let you take it because I know you're a little bit time limited.
Well, Larry, thank you for the introduction, and we're happy to work with cool and innovative companies such as BadElf. Let me start with introducing our company first and what we do to set the context. VGIS is the company solely dedicated to visualizing spatial data in augmented and mixed reality. What it means is that we take anything that has coordinates, latitude, longitude, elevation, and then we build augmented reality visuals with that data. We have strong partnerships in that space. In addition to our partnership with companies such as BadElf, we're also silver partner of Esri. We're silver partner of Microsoft. We finalizing our partnership with Autodesk and Bentley right now. And we also received a few awards from our partners, including Esri Partner Award 2 years ago. And for 3 years running, Microsoft names us as their finalist in the Partner of the Year category. The main objective of the system is to visualize digital twin in the novel way. We want to take anything that exists only in digital form or something that exists already under the surface of the road and you cannot see, and then bring those visuals to life through augmented and mixed reality. In doing so, we rely on multiple tools. We are platform agnostic in every possible sense. We work with Microsoft HoloLens. We work with tablets and phones, iOS, Android, and we bring digital twin in the form of GIS data. That's what you see on the screen right now. Or BIM data, or even reality capture data. If you're wondering what's the main purpose of the system, it can be described as reducing reliance on 2D maps. 2D maps and schematics, blueprints, they have their place in the world, but the biggest issue with 2D maps is that the process of reading maps is time-consuming and error-prone. And we believe that by replacing it with natural view of 3D visuals, we can improve the perception. We can remove some of the mistakes that people commonly do in the field, and we can help you shorten the time that it takes you to get oriented in space. As the result, we can bring visuals such as BIM, for example, and place a building to be constructed in the accurate location using mixed reality. That BIM information can come directly from sources such as BIM 360, Bentley iTwin services, native BIM files such as IFC and DWG, and then you can visualize it with high accuracy of up to 1 centimeter on site. In addition to BIM, you can work with GIS data. So this is an example of what our GIS data looks in VGIS. We consume native URLs from Esri. We consume points and lines, and on the fly, convert them into 3D visuals based on the client specs. The model is built automatically by our system on the background in real time. So all the color coding, symbology, different sizes and shapes are applied dynamically based on your data and the attributes within your data set. So as your data changes, you don't need to build a new model by hand. Our system will do it for you. Efficient data management is built into the system. So if you're walking in VGIS, it will dynamically preload data in the distance and display it as you keep moving in one direction. And you have access to all the attributes within your data set. So by tapping on the digital twin, you can pull up additional information about that object. And if you work with Esri backend, then you can even modify that information directly in the field to correct different attributes. Another aspect of our system is presentation of reality capture. Reality mesh, point cloud can be presented, not so much point cloud, but if it's converted into reality mesh, can be placed in augmented reality or mixed reality view with centimeter level accuracy. So if you had previously excavated place, then you can time travel essentially by going back to the site and see what the excavated trench looked like long after it was filled. This can be used in conjunction with actual excavations. It can be used in conjunction with construction project where you can capture work in progress and then refer to different stages of construction. And the best part is that this component of VGIS allows you to bring your own reality capture. So if you work with tools such as Bentley or Esri, then you can bring reality capture from those tools. If you don't have access to reality capture capabilities at the moment, VGIS has reality capture built in. You can simply use your phone and then scan the ground with your phone, nothing else. And VGIS will convert that video stream into a 3D model, georeference 3D model, and that model will be available to the entire organization to see. So VGIS is currently the only system on the market that can take data from multiple data sources at once, from multiple, often incompatible formats at once, and then combine the data on the fly in real time without much delay into unified AR views and present it on the device. Displaying data in AR is only half the equation. We also understand that you need to be able to do something with that data. So our system has workflows that allow you to facilitate bidirectional communication with your teammates. So if you notice a discrepancy, you can, for example, report on that discrepancy in VGIS. And when you report on it, the recipient will receive the exact location of where the report was taken. You know which way the person was facing, what they saw, and you can take necessary corrective actions based on the report provided by somebody from the field. You can also use virtual tags to label objects in space. This is a very useful feature if you're going through different construction projects and you identified problems that are spatially referenced, for example, rusty pipe or broken, damaged object, then you can label that object. You can associate tags with the digital twin. So from the backend, it can be exported as a fully linked relationship, and you can create job requests or work tickets based on that. And the best part is that this type of visuals will remain in space after you leave the job site for other person to see. And if you label something in the field and I come back a month later, I will be able to see all the same tags that you left for me. VGIS comes with data collection capabilities. We are able to take data and collect at the moment points and shortly lines and polygons with survey grade accuracy using GNSS or without GNSS. And you can use it as a AR-based data collection tool. The system, if you use it with Hall, it also allows you to zoom out from your location and see yourself in real time on a holographic map with all the GIS features superimposed around you. That map looks and feels real, so it feels like you can touch it, and it gives you a great understanding of your surrounding area. That view can be broadcasted across devices, and if you are in a situation that you need to have somebody to guide you through an issue, you can simply share your screen. They will be able to see what you see in real time with physical world and holographic overlays combined. And because you can maintain two-way communication in that web view, you will be able to receive guidance, real-time guidance. And during the times of COVID, it becomes a very useful feature because not everybody can be in the field all at once. And therefore, having access or having somebody on site walking around and showing AR overlays in real time, changing transparency, doing the cross-section planes, while the rest of the team watches it over the web conferencing solution, is very useful. We have approximately 100 clients globally, including many construction companies such as John Holland, Skanska, Atkins. Those are few of them. Oil and gas, municipalities, public utilities, United Army Corps of Engineers, United States Army Corps of Engineers, United States Air Force are among our clients. And the use cases that we can identify for such a solution is as follows. First, it enables connected worker to collaborate with your data in real time. So as you accumulate BIM GIS data, the system lets you use the same data you already have in a novel way. We can support multiple devices from Microsoft HoloLens to iOS and Android, so you can use any device that is suitable for a specific job, and you can optimize your deployment for a specific application, be that engineering or be that traditional maintenance work. And among the use cases is, of course, a digital twin visualization. That's something that helps you understand structures and propose construction before you start building anything. It can be also used for design reviews. So in this case, if you're using HoloLens, I can remain hands-free to do my job, and I can see and visualize different elements in space in real time so that I can see what those, for example, towers in this case, will look like once everything is built, and I can see how they blend into the neighborhood. Subsurface utility visualization is the key. If you have a really complex project, you're relocating utilities, or you're trying to visualize existing utilities, then it's a very useful tool that's been deployed by many companies in that capacity. We are also capable of visualizing GPR scans. And our LinkedIn profile has a very good video that shows it, how to do it in real time. And of course, reality capture. Reality capture lets you time travel because you take the model, you just use your phone. So what you see right now is direct recording from my phone, from the screen when I'm standing in the field. And I can walk around that particular trench and see it exactly the way it was when it was opened. And at this point, I want to open the floor to your questions.
Well, Alex, thanks so much for the presentation. Such an incredible system that you've built up there, and I would actually open to the floor for pay homage to the survey community. I think there might be some definite interest in how they might be able to use a system such as yours. So, Kent, looks like you have a question.
Hey, Alec. My name's Kent Groh. I'm a professional land surveyor, and this is absolutely amazing. I'm curious, and this would probably be a really simple application for it, but for like a boundary surveyor, let's say, could they incorporate this technology into boundary surveying? And I guess what I mean by that is once property boundaries are established, could you use the technology to like literally see the property line while wearing the glasses, let's say, and using the tablet? Could you see the property line in relation to the physical attributes in the field?
Yes, you can. So it's probably one of the easiest visualizations for us to do.
Yep.
And in fact, we work with Singapore Land Authority and few other companies that use it in that capacity. Not strictly in that capacity, because they use it for other things as well, but that's something that can be done definitely. Our system has understanding of different of terrains. So we incorporate digital terrain models into visuals that we present. So for land surveying, you can, if you use it for describing, let's say, something to the property owner, or just visualizing something on site, it can be a helpful tool. Probably wouldn't unlock the full power of that, and we will compete with traditional maps in that case, but certainly it can be used in that capacity.
So Kent, How would you see this potentially used in something like a stakeout?
I'll be honest with you, I'm trying to wrap my brain around it right now. It's the first time I've actually, I mean, you know, you see these videos on like LinkedIn and Facebook and stuff like that, but this is the first time I've really, you know, I guess focused and you know, seeing a presentation like this. And, you know, my mind honestly just racing at the moment. I mean, I'm thinking of so many different applications for this technology as it pertains to, you know, boundary surveying. You know, obviously it's a tool that, you know, could be used for topographic surveys and really just about anything we can do. I can see an application for it, but let me get back to you on that because, like I said, I'm just trying to wrap my brain around this right now.
Okay. Will, I see you got a question.
Yes, yes, Alec, that was awesome. That was the kind of stuff I used to dream about when I was a kid, you know, like God, if I could just, you know, show you what I'm talking about, like where the line is or where, I don't know, it's really cool. But like what Ken was talking about with the boundaries, I mean, I can think of a million use cases where I could just take people out and say, look, you know, your line is right there and your fence is this far over. And, you know, I can't, you know, maybe there's an object in the way or an angry neighbor that you don't want to go step in their yard, and you can say, hey, put these on and look over there and you can see for yourself, you know. But I think that's just, you know, only scratching the surface capabilities that I saw Dr. Nick had some students using it out in front of the survey shop down in Allen's one day, and I pulled up and I was watching them, and it kind of let me come over, and I don't know what system they were using, but they had gone in there and tied down the utilities in the trenches before they backfilled. And then they had called blue stake out there and they were tying down the blue stake and, you know, referencing the blue stake with where it actually was. And I just thought that was just, I mean, really cool. So.
And it's interesting that you're bringing it up because our recent client is Barton Mello in Michigan. So they are developing a few, I would say, greenfield or brownfield subdivisions. So the use case for them is quite similar. So they did all the stakeouts. They know where the subsurface infrastructure is. And before they start any construction, everything is very easy to see because you have all the stakes in the ground. But once the people start moving through the site, once machinery is on site, all those stakes are gone. And they surveyed it up until that point. And the difficulty is, what do you do with this information? So right now, they're applying VGIS, and they can see all the stakes exactly where they were. We actually have gone, before we got to the production stage, they've gone through almost a year of testing with us. And what confirmed that the system can be used in that capacity is that they had it out in the field for several weeks, and every single time it was with probably 2-3 centimeter level accuracy over the stake. So you can walk through the open field. So instead of looking at the physical stakes, you can look at the augmented reality, and it's much more descriptive because you can bring more information. You can bring property boundaries, you can lot boundaries, subsurface utilities, all in a single unified view.
Yeah, and I mean, especially if you have the capability to scan this stuff with your phone, I mean, I can't count how many times we've had a contractor saying, you know, we need you to get out here and shoot, you know, come as built this pipe because we want to bury it. And we're like, well, we can't get out there. But if he at least has the capability in his phone to jump out there and scan that trench and that pipe, and then, you know, at least we have some evidence. And if we can tie that back into our, you know, our coordinate system and our, you know, hopefully virtual network, then that's just, I mean, plus, you know, as a safety factor, when you got pipe that's buried 30 feet down and you don't want to send a guy down there, and you can fly a drone over the top of that trench and collect all that data and still be able to utilize that, you know, later down the road. That's, I mean, that's awesome.
Yep. And for drones specifically, we can get information from services like Esri. So you can publish the data in Esri ArcGIS, and we can retrieve drone information from ArcGIS and use it in the system later on.
And can you, like, if you had a client who's collecting their own collecting their own drone data or scanning data, they can send that to you and you can help them out producing these models?
Well, they have to convert, so we consume the models. So they will have to produce models first. There are tons of tools that can help you do that, and we can do it directly from the system. So we are not a service company, so we wouldn't necessarily strive to help somebody with producing anything. But in terms of visualizing what they already have, this is what we are good at. This is what our specialty is.
Gotcha. Okay. So how are those holographic models built?
Which ones? The reality capture? Or
yes.
So reality capture is typically done through photogrammetry. You send the video stream directly from your phone, and that video stream is processed by our servers, and then we have georeferencing for every frame. So the system understands where different frames are in space, and then builds model based on the pixel analysis in the frame.
Gotcha. Okay. Thank you.
And I must apologize, but I seems like really out of time today, and my apologies. But if you have any time, if you have any further questions, Larry and Nick have my email. Please don't hesitate to ask. It doesn't have to be business related. We will be happy to chat and respond to your queries, even if they are not VGIS related, just general industry inquiries.
Alec, I just want to thank you so much for presenting today and sharing with the group. I think it's been very enlightening, and I'm very excited to see how we could use your technology in this particular industry. So thank you again for joining us.
And thank you for having me, Larry, and all the best with the webinar.
You bet.
Have a good one.
You bet. Take
Bye.
care.